Hello, everyone, and welcome to our systematization of knowledge presentation, Anatomy of Data Breaches. My name is Hamza Saleem, and I am a PhD student at University of Southern California. And this work was done in collaboration with my professor, Muhammad Naveed. So let's get started. I'll start off by giving you some background. So we all know that we are living in the age of big data, where companies and governments today have greater access to our sensitive data than ever before in our history. This data includes personally identifiable information, data about our medical records, our financial data, even data about our location. This listing on the left side can give you some idea of how much data each of these big companies are collecting from us each minute. So the companies use this data to improve their processes and meet the demands of increasing tech-savvy population. Many companies actually depend on the data we provide them to survive the competition. Now, collecting data on such a massive scale certainly has its own privacy implications if this data is disclosed to any unauthorized parties. A data breach is such an incident that involves intentional or unintentional disclosure of data to unauthorized parties. The data which is leaked in a data breach could include confidential information regarding an individual user, an organization, or even a country. So in terms of individual users such as ourselves, this data could include any personally identifiable information such as our name, our address, our email, our phone numbers. Similarly, this data could include any medical records or payment card information. In case of an organization, this data could reveal the internal workings of an organization or could include data about their employees, such as their salaries or information about their dependents. This data could also include any intellectual property, such as source code in case of tech companies. And in case of a country, this data could reveal trade secrets to foreign entities in case of a data breach. Data breaches are among the most important computer security and privacy problems we have today. It is routine for the attackers to steal millions or even billions of user records. I'm sure that most of us here have heard such stories involving big organizations that have suffered a data breach. But there are even more such incidents that either even involve small businesses or medium-sized businesses that do not even make it to our news. So apart from the privacy implications these incidents have on the individual users, the data breaches also cost a lot to the victim organizations. These costs are generally associated with the investigation and litigation costs of these incidents. This chart here is taken from the Ponemon Institute's report, Cost of a Data Breach 2019, and it shows the average cost per record for a data breach for different industries in the US. We can see here that the health sector has the highest cost per record for a data breach, which is about $429. After the healthcare industry are the finance and the technology industries that have the highest average per record cost for a data breach. In order to motivate our study of data breaches, I'll start off by describing why it is important to study data breaches in the first place. So first of all, despite their prevalence, these incidents have not yet received due attention from the security and privacy community, and there is lack of research to understand how data breaches occur in real life. Data breaches are usually considered outcomes of other security issues such as human error and software vulnerabilities. There's also lack of academic literature, which makes it hard to develop comprehensive understanding of how these data breaches take place. Another problem is the lacking of systematization of common attack methods that the adversaries use, and also the capabilities of existing security technologies to prevent data breaches is mostly unknown. So all these challenges makes it hard to identify what are the security gaps that still allow these breaches to occur, and how can we design efficient defenses to prevent such incidents. Given these challenges, I'll describe what are the contributions of our work. First of all, we developed a systematic analysis method to study data breach incidents. This is a general method and can be used by anyone who's trying to study data breaches. We use this method to study 10 famous data breach incidents of the past. We develop detailed step-by-step workflows of these incidents, describing how the attackers breached data in each case. After that, we study 50 breaches from the year 2015. By studying these breaches, we systematize the various attack methods that the attackers use, and we develop a general breach workflow. In order to understand the capabilities of the existing security technologies, we first of all come up with a list of security requirements that we think are important to prevent data breaches. After that, we analyze the existing security technologies to see which of these requirements can be fulfilled by these tools. We also identify the gaps and in the end we provide future research directions that can fill in these gaps. Briefly describe the systematic analysis method that we used in our study. So first of all, we conducted the information analysis in which we thoroughly studied all publicly available relevant information to each data breach to develop breach workflows. This included investigation reports from victim organizations. Uh, this also included online articles published by various news and blog websites such as New York Times and Wired. We also studied various independent investigations that were conducted by security researchers. After the information analysis, we performed the malware analysis in which we thoroughly studied the malware used in different incidents to understand its capabilities. We also conducted attacker group analysis in which in cases where the attacker groups involved in a data breach were known, we studied the past incidents in which these groups have been involved in to understand what are the capabilities of these attacker groups and what are the common breach methods that they use. We also studied the vulnerable software in detail to understand how the attackers exploited this software. Apart from that, we also studied past data breach incidents that are linked or related to our present incident. To give the audience a flavor of our analysis of the 10 data breach incidents, I will discuss the Yahoo data breach today. So in 2014, a state-sponsored attacker group breached Yahoo, stealing accounts information of over 500 million users. The attackers generated forged authentication cookies to gain access to email accounts of various Russian journalists, the United States and Russian government officials, and many private sector employees. They also diverted Yahoo's search engine traffic to certain websites for monetary profit. They later sold the stolen accounts on a dark web marketplace for profit. So the breach started with the attackers sending spear phishing emails to the Yahoo employees. The attackers harvested their credentials using these emails, and they used these stolen credentials to gain access to Yahoo's internal network. They also installed additional backdoors and malwares to gain persistent access to Yahoo's internal network. From this access, they spread across the whole network and infected a number of different machines. Eventually, they gained access to the user database that stores the information about Yahoo's users, such as their emails, their usernames, their email addresses, their date of births, and other information. And they also gained access to the account management tool, which is used to query this database. So first of all, they exfiltrated a backup copy of this database, which had around 500 million user accounts. After that, they used the account management tool to query this database to find the different accounts of government officials and journalists, the email accounts in which they were actually interested in. So after identifying these email accounts, they still needed passwords to gain access to these email accounts. But the passwords in the user database were actually hashed using the bcrypt algorithm, which is considered a secure hashing algorithm. So in order to gain access to these email accounts without the password, they use the cryptographic nonce associated with each account along with the script that is used to generate authentication cookies. So they use this to generate forged authentication cookies. So these forged cookies allowed them to access more than 6,500 email accounts, the accounts that they were interested in. And using this access, they exfiltrated all the information of interest from these user accounts. Similar to Yahoo data breach, we analyzed 9 other breach incidents, including the Target data breach, Anthem, and Edward Snowden's hack of the NSA. Here is a listing from the paper that systematizes these 10 incidents. We provide information about the data stolen in each case. We also describe how these organizations discovered the data breaches. We also detail the various techniques that the attackers used in each breach, including spear phishing emails, exploiting various software vulnerabilities, and using stolen credentials for access. We also describe various techniques used by the attackers to hide their malicious activities, including using DDoS attacks for diversion or clearing activity logs after the attack. We also provide information about the security tools that we think could have made the attacker's job harder during the data breach. Please take a look at the paper to gain more information about this listing. So while the 10 case studies contain detailed step-by-step workflows, in order to systematize breach methods, it is important to understand if these case studies paint a comprehensive picture of the techniques used by the attackers. For this purpose, we studied 50 data breaches from the year 2015 to systematize the attack methods used by the attackers and also to develop a more general data breach workflow. So this chart here shows the number of records stolen in these 50 data breaches. We can see that for 62% of the cases, the number of records stolen were less than 0.1 million, which means that the attackers mostly targeted small or medium-sized businesses. For just 8% of the cases, the number of records exceeded the 10 million mark. For the attacker type, we found that in most cases, the attackers were cyber criminals that were trying to get some monetary benefit. In just 8% of the cases, the attackers were state-sponsored. And for the data records type, we found that in 68% cases, the attackers stole personally identifiable information. In 16% cases, they stole user account information, such as emails and passwords. And in just 4% of the cases, they stole the financial information. This listing shows the various industries that the attackers targeted. We can see that for about 28% of the cases, they targeted healthcare sector. The government, technology, and retail sectors were also commonly targeted by the attackers. This chart shows the techniques that were commonly used by the attackers during these attacks. We can see that the attackers often exploited some sort of software vulnerabilities, or they would target third parties associated with the victim company. They also often stole devices that contain sensitive data, and they also use social engineering techniques. Briefly describe the common breach methods that the attackers used in our 50 data breaches. The first one is the human error. We often found the attackers exploiting human error, for example, social engineering techniques to steal the employee's credentials or deliver malware. We also found attackers exploiting password reuse. The employees in some cases were storing plain text passwords on their machine, which helped the attackers to spread during the later movement phases. We also found the attackers exploiting outdated software during their attacks. The attackers also exploited well-known vulnerabilities, which the companies had not patched yet. The attackers also compromised the third parties that were associated with the companies. The third parties are any entities that the organizations do business with and could include vendors, partners, or software or hardware solution providers. So the attackers would first compromise these third parties and use their access to compromise the victim organizations. We also found attackers exploiting lack of multi-factor authentication. The attackers also often hide the malicious activities using various techniques. such as clearing activity logs or using obfuscated malware. We also found attackers using concurrent attacks to divert the company attention. Apart from these breach methods, we also found the attackers exploiting other methods which we did not found in the study of our 10 cases. This include accidental loss, where the employees inadvertently disclose the company's data, for example, by making the database publicly available on the internet. We also found cases of mergers where one of the companies in a merger was already compromised and the breach was only discovered afterwards. We also found cases where the employees took some data off premises and the attackers stole this data from the employee. This slide shows the general data breach workflow we developed after studying the 10 famous data breach incidents and the 50 data breaches from the year 2015. These blue rectangles show the initial attack vector used by the attackers, which includes social engineering techniques, exploiting software vulnerabilities, exploiting stolen credentials, using malicious insiders. After gaining the initial access, the attackers use various techniques like escalating privileges, or they spread across the network, or they installed additional malware, and eventually they were able to exfiltrate the data. Please take a look at the paper to go gain more information about this workflow. After systematizing the common attack methods, we also studied the capabilities of existing security technologies to prevent data breaches. For this purpose, first of all, we identified the entities that are related to an organization, such as the third parties they do business with, or the employees on their network devices, and we developed 57 security requirements related to these entities that we think are important if the companies want to prevent data breaches. After identifying these security requirements, we studied 84 security technologies. We studied their capabilities and tried to reason if these security technologies can help the companies address these security requirements. Apart from that, we also identified a number of promising future research directions that we think can help the organizations fill the gap that is left by the existing security technologies. This listing is taken from the paper and it shows the various security requirements we identified to keep the organization secure from data breaches. It includes detecting and blocking phishing attempts, and preventing employees from uploading sensitive data to the internet, and many other requirements. This part shows how the existing security technologies can help the companies implement these requirements. We found that only 2 of these requirements can be implemented fully, whereas 55 of the requirements can only be partially addressed by the existing security tools. So we propose a number of promising future directions that can help fill this gap left by the existing security technologies. Please take a look at the paper to get more information about this listing. I'll state some of the important future directions that we identify in our work. First of all, we believe that storing the data at multiple servers and using multi-party computation to compute on data could make the attacker's job significantly harder, because now they'll have to compromise a number of servers before they can access the sensitive data. Another promising direction is to use trusted hardware. We believe that encrypting sensitive databases and storing the cryptographic keys using trusted hardware and limiting the number of records that could be retrieved from the server could go a long way towards preventing data breaches. We also believe that it is important to invest more research efforts in improving the usability of the existing security technologies. Apart from that, since many data breaches are caused by unpatched software, we also believe that more research is needed to automate the software update process in a non-disruptive fashion. Finally, inspired by the principle of least privilege, we propose the principle of least data retention, and we encourage organizations to retain the minimum amount of data needed for their operations. To conclude, in this work, we systematized information about how attackers breach data by developing the most plausible step-by-step data breach workflows for 10 famous data breach incidents, followed by a study of 50 random data breaches. We believe that a promising way to protect our data is to understand how attackers breach data, tackle the data breaches as a holistic problem, and develop threat models capturing real-world attacker behavior. Thank you.